Okay, hello, welcome back. So now we shall be going through the 2017 paper 3. Okay, so I will go through selected questions that I want to discuss further in detail. Okay, for the rest of the questions, you will find the answers in OneNote. So let's just start. This is 2017 paper 3. Question 1. Now, question 1 is really direct. Okay, so I shall not be spending too much time on it. So you just need to know that water is a compound. Okay, it's made up of hydrogen and oxygen atoms. Steel is an alloy. Alloys are mixtures. Okay, so steel contains iron and carbon. Finally, air is a mixture that contains nitrogen, oxygen, and argon atoms. All right, so that's how you get 6 marks. Now, for the one on air, I would strongly recommend writing all 3 atoms, nitrogen, oxygen, and argon, because these are the 3 main components of air. All right, so with that, we score the first 6 marks. As you can see, it is really scoreable. Next, now question 2, they asked you to name a group in the periodic table. Can we please take note, when they ask you to name a group, don't just write group 7 or group 1. Make sure you write down the name of the group. So for example, group 7, they are called halogens. Okay, so for part A, I've chosen halogens, group 7. The trend in the physical property. So you recall, physical property is like melting point, color. So we know that the group 7 elements become darker down the group. Next, part B, the alkali metals, group 1. What is a chemical property that is similar for all the elements in group 1? So I've chosen to say that they react with water to form the metal hydroxide solution and hydrogen gas. Okay? Can? So that's question 2. So I'm going to give you a bit of time to copy down. Now, if you have forgotten group 1 and group 7, please revise the summary notes for the periodic table. We have also done a summary on this before. So I would like you to revise these things, please. Okay. All right, I shall move on to question 3 now. Now, question 3, actually, you recognize is quite similar to your prelim. All right, it is just drawing the structures and completing a table. I don't think it's very difficult to do question 3. All right, in fact, question 3, I will put it as one of the simpler organic chem questions that you should score full marks for. Okay, so if there's only one reason why you don't score full marks, which is you may not have been careful when drawing all the bonds in. Please ensure that you've drawn all the bonds in. Make sure that every single carbon atom has only 4 bonds around itself. Please
Mr.
count.
Cho,
yes.
Why is the ethane under alkenes?
Oh, sorry, it's ethane. Sorry, it's ethane. Oh, yes, that's a good point. Okay, I'm sorry. Okay, it's ethane, so it's alkanes. Okay, I misread. Okay, thank you for pointing that out. Okay, so everyone, please take note. Okay, there was an error here. Ethane is an alkane, so this is the structure of ethane. All right, so later on, when informing the class, I'll also inform them that in the video recording, there was a slight mistake. Now they must watch the full thing to ensure that they get the correct version. Okay? Yes, Shami, thank you. So it's alkanes, ethane. Okay? So if I may move on, please give me a thumbs up so that I know that I can move on. Okay, so question 4 as well. Question 4 is a more concept question. In fact, you will recognize question 4 because question 4 is very similar to your prelims, right? Question 4, basically we are calculating the concentration in grams per dmq and moles per dmq. As mentioned, this is a popular question in the O-level combined science paper. So for grams per dmq, we will take the grams divided by the volume, but remember the volume has to be converted into dmq. So if you do it correctly, you will get 212 grams per dmq. Then to convert from grams per dmq to moles per dmq, we just divide by the mR. So make sure you calculate the mR correctly. There are 2 sodium, so it's 2 times 23. Okay, so 2 times 23. Okay, this is important. 12 because 1 carbon, and then you have 3 oxygens, 3 times 16. All right. For the equation wise, I think it's not difficult. Once you manage to balance it correctly, it should be quite straightforward. Okay. Now, as mentioned for equations, the temptation is always to write formula wrongly, so that's convenient, right? You see there's Na2CO3, so the temptation is to write Na2Cl, which is wrong. Sodium chloride is NaCl. So you must put the 2 in front of NaCl. All right. Finally, calculating number of moles. I think that's not difficult. First step is 25 cm cube of sodium carbonate. So in 25 cm cube of the sodium carbonate solution, how many moles of sodium carbonate do you have? You will take the volume times the concentration. What's the concentration? 2 moles per dm cube. You will use the moles per dm cube concentration. All right, so you use this here. That will give you 0.05 moles. And hence, using the mole ratio of 1:2 from the equation, that will give you 0.1 moles of HCl needed. All right. Okay, so I shall leave it at this screen for you to take down first. So we have already finished questions 1, 2, 3, and 4. As you can see, right, questions 1, 2, 3, and 4, they amount to 19 marks. 19 marks out of 65 are actually quite straightforward. All right. Okay, if I move on, please give me a thumbs up so that I know that I can move on. Okay, but of course, if there are any questions or if I made an error as well, please stop me as well to correct me like just now. Okay, Alia, okay? Brandon?
Yes, I'm fine.
Okay, now let's move on. Now, question 5, the first part is not difficult. Sodium hydroxide is an alkali, so give 2 chemical properties. So as mentioned just now for the previous paper, chemical properties means reactions. What are the reactions that alkalis will undergo? So alkalis will react with acids to form salt and water. So of course, this is your neutralization reaction. Now, but besides that, the second reaction most students will forget, which is the base plus ammonium compound. So alkalis and bases, they react with ammonium compounds to form salt, ammonia gas, and water. All right. So these are the 2 reactions of alkalis. In particular, the second one, I think most students will forget. So I hope you don't forget that they react with ammonium compounds to form salt, ammonia gas, and water. Okay, part B. Many plants grow better in alkaline soils than in acidic soils. Name and give the chemical formula of the ion that causes soils to be alkaline. They want the ion. They do not want things like sodium hydroxide, calcium hydroxide. They want the ion. So which ion is responsible for alkaline properties? All alkalis have which ion? The answer is hydroxide. The formula is OH minus. So this was a common mistake in 2017 because virtually everyone studied and virtually everyone wrote calcium hydroxide. Because they remember soil. Soil, just put calcium hydroxide. But you must read the question. They're asking you for the ion. Calcium hydroxide is not an ion, it's a compound. We are interested in the word hydroxide. Okay? So part C, explain how the acidity in soils can be removed and how the pH changes. So this was another trick question. Most students know we add calcium hydroxide. we will add calcium hydroxide to remove the excess acids in soil. Right? This one, most of you know this. All right? This is only 1 mark. Why only 1 mark? Because there are 2 marks to this question. There are 2 parts, right? This is the second part. You need to see how the pH changes. So the pH of the soil will increase. Why does it increase? The concentration of acid decreases, right? As the acid is being removed through neutralization, the concentration of the acid will decrease. Hence, the pH will increase. Okay, so I shall leave it as question 5. Okay, for you to take down. Okay, once you have finished question 5, can you give me a thumbs up so that we go on to question 6. Now, I intend to go through question 6, 7, okay, 8 quickly as well. Okay, let's move on. Now, 6A is easy. I'm sure you can do 6A yourself. All right. Okay, just give me a minute. I think the screen is a bit lagging. Okay, let me try to stop sharing first. Okay, I'm going to pause the recording for a while. All right, welcome back. So there was some technical difficulties. So now we have resumed recording. All right, so 6A, the test for sulfate ions, I think is quite straightforward. Okay, so we add acidified barium nitrate solution and you form a white precipitate. This is not the difficult part. The difficult part is 6B. So I've mentioned in class, okay, this is your 2-step salt preparation. Okay, how you know it's the 2-step question? Because you are preparing an insoluble salt, lead-2 sulfate, but you must start from lead-2 oxide. So the first step is you must react lead-2 oxide with nitric acid to make lead-2 nitrate. Okay, so this is a 2-step salt prep. The first step is to make lead-2 nitrate. Then the second step is precipitation. Okay, so this is similar to 2012, I think. Yeah, 2012, question 9. Okay, so you might want to later go back and look at 2012 question 9 as well. This is a similar question. It came out only in 2012 and 2017. In 2017, this was one of the worst done questions. All right, so you must learn how to do this kind of 2-step salt prep. How you know it's 2-step? You know it's 2-step when you see the bullet points of information. You know it's 2-step when you're trying to prepare an insoluble salt like lead-2 sulfate from a solid like lead-2 oxide. You can't start with the solid. You need an aqueous solution for precipitation. So you know that you need to use lead-2 oxide to make an aqueous solution first, like lead-2 nitrate. So what's the first step? We will add excess lead-2 oxide to nitric acid and stir until no more reaction takes place. Okay, so this is the standard, adding excess solid into an acid. Then we will filter to remove the excess lead-2 oxide. Okay, so standard, right? You add excess already, then you remove by filtration. Third step, to the filtrate solution. Now, filtrate is the one that passes through the filter paper. The filtrate is lead-2 nitrate. Because it has reacted with nitric acid, so it's lead-2 nitrate now. To the filtrate solution, we add an equal volume of sodium sulfate solution. Now, this is your precipitation, all right? Then how do you do this? You filter to collect the lead-2 sulfate as a residue. Then we have to wash the residue with a little cold distilled water. And dry between sheets of filter paper. Okay, so these are the steps. So you realize that the first part is just basically acid plus excess base. The next few steps is your precipitation. Okay, so it's a two-step salt prep. Okay, so I shall leave it as this. Please take down quickly. And then we're going to question 7. Now, question 7 has a yes.
Sorry, Mr. So, for question 5A, answer I put alkalis produce hydroxide ion.
When dissolved in water.
Right? Does that consider as a
yes, it's a chemical property. That's fine. But you must write down when dissolved in water.
Then how about alkalis have a pH value more than 7?
No, pH is not a chemical property.
Physical, is it?
Yes, it will count as a physical property.
Okay. Thank you.
Okay, I hope you have taken 6B down. This two-step salt prep. Okay, if you're done with question 6, can you give me a thumbs up so that I know you're done and I'll move on. Now, question 6, okay, it's not difficult, but you just need to know what's going on, all right? Now, again, it's always important to highlight keywords. Keywords like metals. These are metals reacting with sulfuric acid. So obviously, this means the gas produced is hydrogen gas. Right? So now, they added 0.5 mole of the powdered metal to an excess of the acid. This is important. Again, the acid is excess, so this is the metal is the limiting reactant. All right. And they measured mass and they plotted loss in mass against time. Remember, loss in mass is equals to the mass of the gas. Okay, so just remember this. This is actually similar to the 2019 paper that we did, where we talked about loss in mass. The decrease in the mass is equals to the mass of the gas. Okay. Now, so they were asked, explain why the total mass decreased. Why did the mass decrease? Escaped from the flask or from the setup. So when the hydrogen gas produced escapes, of course, the mass will decrease. Okay. Now, if you look at the four metals, right, immediately it's clear, right? Metal 1 had no change in mass, you know. Metal 1 had no loss of mass. We just said loss of mass means it's due to the gas, right? If the mass didn't lose, that means there is no gas formed. Metal 1 doesn't form any gas. That's why metal 1 is not reactive with acid. It is unreactive with acid. So metal 1 doesn't react. Whereas, which one stopped reacting the fastest? Metal 4, right? Metal 4 stopped reacting really quickly. It stopped reacting at about 140 seconds. So metal 4 was the first to stop reacting. Metal 1 didn't react with the acid. Okay? Now, so C part 1, metal 1 didn't react with the acid. So how about C part 2? Where do you think it's placed in the reactivity series relative to hydrogen? Relative to hydrogen means compared to hydrogen. Where is it? If it doesn't react with acid, metal 1 must be below hydrogen in the reactivity series. Okay, doesn't react with acid equals below hydrogen. Can? So these 4 marks, you should be able to understand quickly and get it. Okay, now D part 1, I must say, was a bit strange to students because they just didn't know how to suggest. It's too open-ended for students. Actually, it's not so difficult, right? Suggest means give me the possibility. For example, metal 1. Metal 1 is the one that doesn't react, right? So which metal doesn't react? Copper. You could also have given me silver. You could also have given me gold. Any of these will work. All right. Can? Then choose another metal lah. Choose some other metal like metal 4. Choose the least reactive and the most reactive for obvious reasons because they are opposite ends, right? Now, metal 4 is calcium, sorry, not calcium, magnesium, or zinc are fine. Now, there are certain metals that cannot choose for metal 4. No calcium. Calcium is wrong. Why? Now, if you look back at the question, I'm using which acid? I'm using sulfuric acid. If I had used calcium metal, it will form calcium sulfate. Calcium sulfate formed is insoluble. Calcium sulfate is an insoluble salt. So it will stop the reaction. Your reaction will not be so smooth and go to completion, cannot. Because if you use calcium, the calcium sulfate form will form a layer, an insoluble layer around the calcium, and it will stop the reaction. So calcium not acceptable. The next one that's not acceptable, sodium, potassium. Why sodium and potassium cannot? These are explosive with acids. You should never add them into acid. So you cannot write metal 4 as sodium, it's not. All right, so let's take note. Even though I say you can give me possibilities, but the possibilities must be logical ones. Okay, finally, the next one, I think the equation not difficult. Let's just write one of them. Let's
So
just
why we cannot use aluminium?
Aluminium?
Yeah,
As which
for
metal? Sorry.
Metal 4.
Metal 4, is it? Let's not use aluminium. Okay, aluminium, right? The problem is that the mole ratio won't be correct.
Oh, okay.
Yeah, this question is tricky in some sense. Okay, because you notice they gave you 0.5 mole of the metal. Metal 4 actually gives you 0 is 1:1. If you had chosen aluminium as the metal, then you will not have a 1:1 mole ratio with hydrogen. So choose something like magnesium, zinc. This will give you a 1:1 ratio. Let's include. All right, as you can see, Shami, when you choose magnesium, the mole ratio is 1:1 with hydrogen. Okay, so that was question 7.
But then you say aluminium, the mole ratio is 1:1. But
It's
then
not 1:1.
Oh, it's not 1:1. Why is that?
Correct. But the question requires the mole ratio to be 1:1. Because you are given numbers. Do you see 0.5 mole of the metal? Then you look at metal 4. Metal 4, the loss in mass is 1 gram, right? 1 gram of hydrogen is 0.5 mole of hydrogen. So that tells you that metal to hydrogen is 0.5 to 0.5 or 1:1.
Oh, okay.
Yeah, so you cannot just anyhow choose a metal. Choose something simpler. Zinc, magnesium.
Okay.
Now, question 8 is complicated. Okay, so I'm hoping to do question 8. I'm hoping to do question 9, 8 as well. Okay, as much of it as possible. And 11A part 2. Okay, let's go to question 8. Now, question 8, right, is difficult because it's not your typical QA. All right, because they actually told you that C is a chloride already. And it has a general formula XCl2. X is a group 2 metal. It's a group 2 metal. All right. So that immediately tells you that probably you can already work out what C is. Right? Just based on the MR. XCl2, right? Cl is 35.5, the mass. You got 2 of it. Then you got X. The whole thing is equals to 159, right? So what is X? If you just do your maths, X is 88, That means X is strontium. How I know 88 is strontium? Cause the question give me ma. Remember the question always help you. They give you all this already. 88, of course, is strontium. So the answer is, of course, C is strontium chloride. Okay, so actually C can be done very easily. C is strontium chloride. It is just based on the information on the MR given to us. We know that it's XCl2. So Cl is 35.5, got 2 of it, so it's 2 times 35.5. So X is 88 lah. Okay, but let's go backwards a little bit. We should always start with the gas. Gas bubble into lime water. This is carbon dioxide gas. Okay, when you bubble carbon dioxide into lime water, you form a white precipitate. The white precipitate is calcium carbonate. So E and D should be easy as well. Now you're going to go backwards. Of course, getting B is harder. Now B must be strontium something, right? If not, where does strontium come from? Right? So B must be strontium something. Then you realize that, oh, it forms strontium chloride and carbon dioxide. Carbon dioxide, trace backwards, always must be a carbonate. Whenever you have CO2, the previous box must be a carbonate. So B is strontium carbonate. So following the trend, A must be strontium something also, right? So you look, what can A be? Is A strontium chloride as well? No, A is strontium nitrate. How I know nitrate? Well, look, what is done to A? I added aluminum powder and NaOH. This is a test for nitrate. So I know that A is a nitrate, strontium nitrate, okay? So that's how you get 5 out of 5. Okay, this was difficult for the 2017 O-level students because it was the first time ever they had to deal with this MR inside the QA. So it shocked many students, I would say, but it's not very difficult so long as you think through the MR. Okay, so the next part, writing the equation, just choose the carbonate plus acid is easier. Okay, I will always choose the carbonate plus acid where possible. It's always easier to write because it's very standard. All right, so that concludes question 8. Okay, so will there be such questions in your exam? I don't know, right? But I can guarantee you there'll be questions that look a bit different. So the truth is you just need to stay calm, think through the MR like I did just now, and you will get the answers really easily. Okay, and if you think about it, for those of you who have done the TYS, actually this question wasn't so hard after all, right? You just needed to think through it calmly. The last thing you should do is to expect everything to be 100% identical to what you studied. Honestly, if everything is so easy and straight out from the notes, then everyone will score well, right? That's not a good thing either at the end of the day, because it means that I'm not challenging your understanding. I'm not really assessing if you can apply knowledge. I don't just want you to memorize stuff. You must memorize, understand, and apply your knowledge. Okay? Now let's go to question 9A quickly. Okay, I know there's a lot of things to cover, but let's do question 9. Okay, now question 9. The relative atomic mass of an atom of boron is 11. Defining relative atomic mass is already a difficult thing for most students. You have to memorize this. These are the things you memorize, definitions, right? So relative atomic mass is the average mass of one atom of the element compared to 1/12 of the mass of a carbon-12 atom. Okay, so this compared to is important. All right, the average mass part is also important. No, so what does this tell you about the mass of an atom of carbon-12? This tells me that an atom of boron is 11 times heavier than 1/12 of the mass of a carbon-12 atom. So the number 11 tells you that it's 11 times heavier than 1/12 of the mass of a carbon-12 atom. All right, so that's how you get 3 marks.
Sure. So for the relative atomic mass, if we were to say we were to compare with, we were to use magnesium, it would be like what, compared to 1 out of,
It's always compared to 1/12 of carbon-12.
or 1 out of,
you will not compare with any other thing.
It's always carbon.
It's always carbon. It must always be 1/12 of the mass of carbon-12.
Okay, okay.
That is the standard.
Because a bit confused with it.
So you don't use any other thing.
Okay.
Okay, so it's always compared to 1/12 of the mass of a carbon-12. Okay. So next, most atoms of boron have that symbol. So what does 11 tell you? What does 5 tell you? The number 5 is the proton number. So an atom of boron has 5 protons in its nucleus. Okay, so you should state what the number is. The proton number is 5, so it has 5 protons. Hence, it also has 5 electrons, as atoms are electrically neutral. So when they say particles in an atom, they are talking about protons, they're talking about electrons. Of course, they are also talking about neutrons, right? The number 11 is the mass number. So there are 11 protons and neutrons. Okay, just let me share the screen again. Okay, so the number 11 is the proton and neutron add together, right? Okay, give me a minute. So the number 11 is the 11 protons and neutrons add together. So there are 6 neutrons. 11 minus 5, 6 neutrons in its nucleus. Okay, so make sure you write as much as you can that is relevant. Okay, this sounds super logical to you, but you need to explain it. Okay, so next part 3, explain why other atoms of boron may have different masses. I'm sure you know this. There are other isotopes of boron, right? This is about isotopes. There are other isotopes of boron with the same number of protons, but different number of neutrons. Okay, so that's about isotopes. So let's just stay at this screen for a while so that you can take this down. Now, owing to time constraints, I don't want to end too late because it's very overwhelming for you. For B, I'm just going to quickly talk about it. Okay, I'll write down the answers later for you to check. So please do check in OneNote. All right. Of course, you also have your answer sheet for the TYS to refer to, but I would much prefer that you check my answers in OneNote as well to ensure that you really get a detailed answer. Okay, so before we move on to B, can I just check that A, part 1, 2, 3, you have finished? If you have finished, give me a thumbs up. Okay, so I'm just going to talk you through B. Now, zinc can be extracted from its oxide by using carbon, and boron is extracted from the oxide using magnesium. This is obviously some reactivity series question about the position of the metal in the reactivity series. All right. So you now have to tell me where is boron, right? Is boron above carbon or below carbon? So quite obviously, carbon cannot be used to extract boron. This means that boron is above carbon in the reactivity series. So carbon cannot displace boron from boron oxide. However, if now you look at magnesium, magnesium can be used because boron is below magnesium in the reactivity series. So magnesium can displace boron. From boron oxide. Okay, so this is clearly about reactivity series. Now for part 2, the main trick is the unit. I think I mentioned this many times yesterday. You cannot use kilograms for mole concept. You must convert to gram before you do mole concept. If you don't convert to gram, your working won't be correct. Okay, so the kilograms, the 10 kg of boron, can you please take note that you will need to convert, all right, to grams before you do something. Okay. Now, I'm not doing the mole concept. I'm just telling you that for 10 kilograms, you need to convert to grams first. All right. So 10 kilograms is 10,000 grams. Okay. Now, I'm just going to stop share for a while because I think it might be lagging as well. Okay, let me just reshare my content, my screen. Okay, we're just going to go straight to 11A part 2. 11A part 2 is quite challenging for the students that year in 2017 because they were not used to planning experiments. Okay. Give me a minute. Let me reshare my screen. Okay, I think it's lagging on my end. Okay, the Zoom is lagging on my end. Now, I will be doing 11A part 2. Okay, let me just go through quickly 11A part 2. Okay, you have it on your end. Now, it's to describe a lab investigation that can be used to see which alloy is more resistant to rusting. All right. Now, I'll be giving you the answers later on, but I really want you to think about what we say about planning experiments. Actually, all you need to say is you place both alloys into water and expose them to air as well, and see after 1 week which alloy has rusted more, right? That's the whole idea. However, when you plan an experiment, please ensure that other variables are kept constant. For example, the 2 alloys, are you going to use a different mass? You're not, right? You're going to keep the mass of the alloy the same. You're going to keep things like the volume of water the same. You're going to keep things like how many days you leave it to rust the same. All right. You must ensure that you leave the other variables constant whenever you have a planning experiment. So very shortly, I will write it on one note. You can check it yourself later. The next thing I want to say is, very often, we think that we should just observe whether it rusts. But the reality is that is not good enough, right? What if both rusted? Then how would you know which one rusts more, right? So how do you actually measure rusting? So I'm not sure if you have thought about it, okay? When something rusts, it goes from iron, Fe, right? Iron. When it rusts, it becomes what? Iron becomes iron oxide, Fe2O3. So now I want you to think, when something rusts, does the mass become heavier or does it become lighter? It went from Fe to Fe2O3. So it's quite obvious, right? Just from the name of it, not only do you have oxygen inside now, all right, you also have more iron. So the mass when something rusts should increase because it has now reacted with oxygen to form the oxide. So how do you tell whether something has rusted more or not? You can measure the mass. See how much the mass increased by. So the one that rusts more should have a heavier mass. The one that rusts less should have a lighter mass. So this is how you do something in rusting. You would measure the mass. All right. The increase in the mass tells you that it has rusted more. All right. So later on, I will show you on my screen because I think now I can't show you because it's lagging on my end. I can't seem to share my screen anymore. But later on, can you go to OneNote and just take a look? As you can see, I've shared screen. It came back. Okay, so maybe I should write it down now while I can share. Oh, okay. So now let's go to question 11A part 2, okay? Okay, let's hope it loads well. So this is the planning experiment, right? Describe a laboratory investigation that can be used to decide which of two different alloys of iron is more resistant to rusting. So it's about rusting. So the first step is you have to place a 2 cm foil of each alloy into, say, a reasonable amount, okay? I would say something like 50 cm cube of water in a beaker. All right, so you can see I give some quantities, right? So that as to ensure it's constant. All right. Next, you leave the foils exposed to water and air for, let's say, 1 week. Okay, nothing shorter than 5 days, please. Rusting really takes time. Remove the foil and measure its mass using an electronic balance. So remember the one that I said, the one that the mass is heavier should have rusted more, right? So the foil with the biggest increase in mass rusted more. Now, if you rust more, that means you are less resistant to rusting. Resistant means you don't rust, all right? So of course, the foil with the smallest increase in mass rusted less. So it is more resistant to to rusting. So this is the perfect answer. Okay, this would get you 4 marks. Okay, so this is how you plan an experiment. It's really not too difficult, really not too difficult. The examiners just want to see that you know what to measure. If you can write this already immediately good, examiner thinks that this is a distinction student. Okay, the examiner wants to see that you can control variables. Control variables means keep other things constant. The examiner wants to see that you know that rusting takes time. Finally, the conclusion is important. The examiner wants to see that you know how to conclude from an experiment. That's it. That's all they need. And it's really not difficult. I didn't even use like all the lines given to me. Okay, so with that, I think we are done with going through 2017. Now, for all the papers that I've gone through, not all the questions I've done, right? Doesn't matter. I will put it up onto OneNote by today. Okay? Can? So once I put it up, I will let your class know through the WhatsApp group. So please stay tuned to the WhatsApp group. Again, don't sleep too late tonight. All right? Just make sure you get enough rest before tomorrow. All right, I shall stop the recording here.